Welcome to Maths with EJD. In this video, I'll be making I'll be talking about rules for finding characteristic equations, and that comes under matrices. So it's important to see how we can find characteristic equations without going through the long process of that we have already been used to. So let's see that. Generally speaking, right, we know that given a square matrix A, the characteristic equation can generally be found using this expression, the determinant of A minus lambda I equals 0. So this was useful for us when we talked about Cayley-Hamilton. So if you have not seen Cayley-Hamilton, check the playlist for matrices. I've done something about that. So A minus lambda I. Then when we also talked about eigenvalues and eigenvectors, we also used this because you cannot get eigenvalues and eigenvectors, or you cannot even solve problems in Cayley-Hamilton if you do not first go through this process. So you need to first of all obtain the characteristic polynomial. Of course, it is the characteristic polynomial that leads to the equation. So if you evaluate this alone, you get the characteristic polynomial. But if you equate it to 0, you get the characteristic equation. So, this alone is the polynomial, but equal to 0 becomes equation, all right? That's important. So without the characteristic polynomial, you cannot do Cayley-Hamilton, and you cannot do eigenvalues and eigenvectors. And then you always know that lambda is a scalar value, and this I, is a unit matrix in the order of A. So if A is a 2 by 2 matrix, I is a 2 by 2 unit matrix. If A is a 3 by 3 matrix, I is a 3 by 3 matrix. If A is a 10 by 10 matrix, I is a 10 by 10 unit matrix. You see, so this is the general way to get characteristic equation. I'm going to go take the pain of going through that process one more time. So now another thing you need to understand is that, however, there are actually efficient rules. There are very efficient rules for obtaining characteristic equations without going through all the process. That's the essence of this video. So let's see how that works. Okay. So let's see this. Imagine that you have a 2 by 2 matrix like this. Okay. Imagine you have, normally, to find the characteristic equation of A, which is 4, 1, 2, 3, we have this determinant of A minus lambda I equals 0. And to do that, I'm going the old way now. So you have A minus lambda I equals 0, and that is 4, 1, 2, 3 minus lambda 0, 0 lambda equals 0. So that's 4 minus lambda, then 1 minus 0 is 1, 2 minus 0 is 2, 3 minus lambda, 3 minus lambda, and that's 0. Okay? And then you find the determinant. So 4 minus lambda multiplied by 3 minus lambda minus 2 times 1, and that is equal to 0. Okay, so we tidy things up. 4 times 3 is 12. 4 times minus lambda minus 4 lambda minus lambda times 3 minus 3 lambda minus lambda times minus lambda, that's plus lambda squared, then minus 2, and that is equal to 0. Okay, so we can tidy things up now. We have lambda squared. I bring that forward so we can follow that order of a polynomial. The minus 4 lambda minus 3 lambda is minus 7 lambda plus 10 equals 0. So now this is our characteristic equation, that is our characteristic equation. But guess what? If you compare the matrix we started with, which is 4, 1, 2, 3, if you compare that with the characteristic polynomial, which is lambda squared minus 7 lambda plus 10 equals 0, see what happens. It can be observed that the trace of this polynomial, the trace is the addition of the main diagonal elements or the principal diagonal elements. So the trace of A is 4 plus 3, and that gives us 7. That 7 is exactly the coefficient of lambda here, as you can see. Then check again. You see that the determinant of the matrix is 4 times 3. So the determinant 4, 1, 2, 3 is 4 times 3 minus 2 times 1. 4 times 3 is 12, minus 2, that's 10. So you see this 10 again is looking like the value you have here. So, and that is what happens for every 2 by 2 matrix. So every 2 by 2 matrix, the characteristic equation is such that you have trace and determinant determining how it looks, okay? So generally, the characteristic equation of a 2 by 2 matrix can be expressed as this: lambda squared minus the trace of lambda plus the determinant of, lambda squared minus the trace of the matrix multiplied by lambda plus the determinant of the matrix equals 0. So this becomes a general way of representing the trace of a matrix. So if you just see a matrix, you don't have to worry yourself and start subtracting or doing anything. Just find the trace, find the determinant, and then you can get your characteristic equation. So we want to practicalize that here. So to find the characteristic equation of B, which is 3, 7 minus 1 minus 2. So we have the trace of B. Instead of having to do all the determinants of B minus lambda I equals 0 thing, instead of doing all this, it's not necessary. Just look for the trace and the determinant of the matrix and you're good. So the trace of B is just the addition of 3 and minus 2. So you have 3 plus minus 2, that's 3 minus 2, which is 1. Then the determinant of B itself now is 3 times minus 2 minus 7 times minus 1. So you have 3 times minus 2 is minus 6. Minus 7 times minus 1 is plus 7. So minus 6 plus 7 is also 1. So you see the trace of B is 1 and the determinant of B is also 1. So you can easily get the characteristic equation. So the characteristic equation of B now is lambda squared minus trace B times lambda plus determinant of B, which is equal to 0. So you have lambda squared minus trace of B is 1, like we found, which is this, then plus determinant of B, which is also 1, and that all of that is equal to 0. So the characteristic equation of matrix B is simply lambda squared minus lambda plus 1 equals 0. Easy peasy. So instead of going through all the stress, you can just do this and you'll be fine. Okay, so let's check for a 3 by 3 matrix where things get a bit more intense. Okay, so let's see this. Things are a bit not as straightforward like we have the board. Of course, there are some overlaps. So let's do this. Okay, it's better I fit everything here at once so we can see. Okay, or let me just do this. Let me expand this first and then we see. Okay, so for a 3 by 3 matrix, right? For a 3 by 3 matrix C, which is A11, A12, A13, and all that, like we know, the characteristic equation can be generally expressed as this: lambda cube minus S1 lambda squared. You see the signs are alternating, plus, minus, like that. So plus lambda cube minus S1 lambda squared plus S2 lambda minus S3 equals 0. Now, all these S1, S2, S3, what are they? That's where the work is. So first of all, S1, like before, like what we found for 2 by 2, S1 is the trace. That is the addition of the elements on the principal diagonal. That's A11 plus A22 plus A33. That's the trace. So that's the sum of the trace of C, which is the sum of the main diagonal element. That's A11 plus A22 plus A33. That is S1. And then for S2, right? S2 is the sum of the minors of the main diagonal elements A11, A22, A33. What that means is that, so you remember the idea of minus under cofactors, under cofactor method and all that for finding the inverse of a matrix. So now you are going to get the minors of A11, A22, and A33. So for instance, the minor for A11 is cross the column and cross the row. So you have A22, A23, A32, A33. And that is exactly what comes here. So for the next one now, we want to find the minor of A22. For the minor of A22, cross the column and cross the row. So you have A11, A13, A11, A13, A31, A33. And that is exactly what we have right here. And then lastly, we need to find the minor of the third element on the principal diagonal. So A33. So cross the row, cross the column. So you have A11, A12, A21, A22. And that is exactly what has come here. Okay. So we find those determinants and sum together. So and we are good. So that's our S2. Then what about the determinant of the S3 now? So don't forget the expression is lambda cube S1 lambda squared, lambda cube minus S1 lambda squared plus S2 lambda minus S3. So S3 is now the determinant of the 3 by 3 matrix, the determinant. Of course, we have found determinant several times. So for that matrix, A11, A12, A13, A21, A22, A23, A31, A32, and A33. For this now, what's the determinant? So if the first thing is you put signs plus, minus, plus. Very important. So you have plus A11, then you cross that row and column. So you have A22, A23, A32, A33 here. And then the next thing you do is to go for the second thing, A12. Okay. So you go for A12. So, and the sign attached to it is minus. So you have minus A12 into cross the column, cross the row. So you have A21, A23, A31, A33, and that's what is here. And lastly, you have plus A13, plus A13, this one. So you have plus A13, cross the column, cross the row. So you have A21, A22, A31, A32 right here. Okay. So that's the way to find S1, S2, and S3. So in addition to 2 by 2 matrix, now you now have the minus coming to play in the case of a 3 by 3 matrix. Okay. So let's take an example to want to find the characteristic equation of this matrix D. Find the characteristic equation of matrix D, which is 3, 2, 1, 4 minus 1, 6, and 7, 3, 5. 3, 2, 1, 4 minus 1, 6, and 7, 3, 5. Normally, you should start saying determinant of, you should start doing determinant of D minus lambda I equals 0, and then you say 3 minus lambda, and you do a lot of trouble and everything, but that's not necessary here. In fact, you're still going to find determinants in that process and all that, but that's not necessary here. All we just need to do is generally the characteristic equation can be expressed as lambda cube minus S1 lambda squared plus S2 lambda, all right, plus S2 lambda minus S3, basically, and all of that is equal to 0. So once you can get that sorted, then the next thing is to find S1, S2, and S3. So first of all, S1 is trace. So the trace of, it's the trace of D in this case, trace of matrix D. So that is 3 plus minus 1 plus 5. So that's 3 minus 1 plus 5. That's 3 minus 1, 2 plus 5. That's 7. So that's the trace of this matrix. And then for the minors, right, we did something close to this previously. So to find the minors of this, of the principal of the elements on the principal diagonal, so we just have this, for 3, cross this out. So you have minus 1, 6, 3, 5. Okay. Then for minus 1, so cross the row, column, cross the row, that's 3, 1, 7, 5. So you have 3, 1, 7, 5. Then lastly, you have for 5, what is the minor for 5? This is 5. So cross the column, the row, cross the column. So you have 3, 2, 4 minus 1. So now all that is left is to tidy up. So tidy this up, you have minus 1 times 5, that's minus 5, minus 3 times 6, minus 18, 3 times 5, 15, minus 7 times 1, that's 7. Then 3 times minus 1, minus 3, minus 4 times 2, that's 8. So minus 5 minus 18 is minus 23. 15 minus 7 is 8. Minus 3 minus 8 is minus 11. So minus 3 plus 8 is minus 15. Minus 15 plus 11 is minus 26. So that is the sum of the minors of the elements on the main diagonal. So the last thing is to find the determinants, which we have found. We have found tons of determinants in the process of this course. So you have 3, 2, 1, 4, minus 1, 6, and then you have 7, 3, and 5. Okay, so we are looking for the determinant of this now. So see what we get. We have this now. So plus, minus, plus. So plus 3 into cross, cross, minus 1, 6, 3, 5. Okay, then minus 2 now. Minus 2, cross, cross, 4, 6, 7, 5. Okay, then plus 1, this, cross, and cross. So you have 4 minus 1, 7, 3. So the next thing is to simplify all these things. Okay, so now I'm going fast because we have done this several times. So you have 3 here into minus 5 minus 18, that's minus 23. Here is 20 minus 42, that's minus 22. You have minus 2 outside here. Then you have plus 1. 4 times 3, 12. minus 7, that's 12 plus 7, that's 19. Okay. So you have 3 times minus 23, minus 69, minus 2 times minus 22, that's plus 44. 1 times 19, that's 19. So minus 19 plus 44 is minus 25. Minus 25 plus 19 is minus 6. So now we have S1, the trace to be 7, S2 is minus 26, and S3 is minus 6. So to get the whole thing out, don't forget the general form is lambda cube minus lambda cube, right? Minus S1 lambda squared, okay? Plus S2 lambda minus S3, all that equals 0. So S1 is minus 7. So we have minus 7 lambda, it's 7, sorry. It's plus 7. The one we got originally is plus 7, yeah? So it's 7. So we have 7 lambda squared. S2 is minus 26, and S3 is minus 6, okay? Minus 6. So we have minus times plus, that's why we have minus 7 here. Plus times minus, that's why we have minus 26 lambda. Then minus times minus, that's why we have plus 6. So for that characteristic, for that matrix, 3 by 3 matrix, the characteristic equation of D, of matrix D, is lambda cubed minus 7 lambda squared minus 26 lambda plus 6 equals 0. And that's how you can do this. So, I mean, you can get a couple of matrices and try your hands on finding their characteristic equations following these rules. Thank you for following this far. Be sure to subscribe and make sure you hit the notification bell so you always get alerted whenever I release a new video. See you in the next one.